All right, guys, so we are going to kind of transition into a new idea. We're going to be looking at how we can use our trig functions in order to solve triangles. So what we're going to start with is something called the law of sines. And I'm going to apologize because I'm realizing right now how loud it is. If you guys can hear a lawnmower in the background, I'm sorry. So we're going to start with the law of sines. So this is how we can use the trig function sine in order to solve triangles. And just as a reminder, solving triangles means solving for all of the side lengths and all of the angles. Okay, so let's just do a quick review on the area of a triangle. So hopefully we all remember that the general form of area of a triangle is 1/2 the base times the height. So if I'm looking at this triangle off to the left, and I said, I'll have my base just be B. So what my height would be, it would be the line, from my opposite angle that is perpendicular to my base. So in this example, my height would be this line right here. So if I wanted to just use the angles and the side lengths that are given to solve the area of the triangle, I would have to find h in terms of my sides and my angles. So law of sines, we're going to try to do this just using the sine function. So what I can do is I can do this a couple different ways. I can look at this angle A and see that the sine of angle A is opposite, so my h value, over my hypotenuse, which is C. And if I multiply both sides by C, I would see that h is C times the sine of A. So one way that I could find the area of this triangle is if I did 1/2 my base times C times the sine of A. The other way that I could do this to solve for the height that I chose right here is if I look at angle C and I see that the sine of C is opposite over hypotenuse, can multiply both sides by A and find that h equals A times the sine of C. So I could also substitute in A times the sine of C for my h value. So I would have 1/2 B times A times the sine of C. And in this case, since my height is coming down from angle B, I can't use angle B with any of my trig functions. So I just wanted to kind of keep this in mind. This is how we could solve the area of the triangle using just our side lengths and our sine function. So let's practice that. I want to do number 1 together, and then we're gonna talk through and come up with some ideas for number 2. So number 1, I am given 2 side lengths. I'm given an angle. So find the area of the triangles. So again, 1/2 base times height. Well, I know that my base is whatever my height is perpendicular to. So my base here is B, or 2.13 times my height. But I don't know what my height is. So I have to use my sine function, just like what I did up here in our example. So the only angle I'm given is A, so I have to use angle A. So I would say the sine of 73 degrees is opposite over hypotenuse, which is 2.96. I can multiply both sides by 2.96 and find that h is approximately 2.83. So I substitute that back in for my H value here. And I would find that the area, I type this into my calculator, is approximately 3.01 meters squared. Okay, so let's start number 2. What we want to do here is we need to figure out what is going to be our height and what is our area. So since we're only given 86, our height has to be something that we can make, that doesn't go through our angle 86. So we could go from the right angle and make 8 feet our base, or we can start here at this left angle and make the 12 feet our base. And that's what I'm gonna do just because that's the angle I chose. It really doesn't make a big difference. Your calculations are just gonna be a little different. So here, if I do this, I know I have 1/2 my base, which is now my 12 feet, times my height, which is what I don't know. I know 12 is my base because it's what I'm perpendicular to. And I'm going to name my height h here. So in order to find h, I'm going to have to use my sine function. So the sine of 86 equals my opposite over my hypotenuse. So h over 8. Then I can multiply both sides by 8 and find that h is approximately 7.98. So my area is 1/2 12 times 7.98. So my area is approximately 47.34 feet squared. So how does this idea of area relate to my law of sines? So we're really going to kind of be looking at all of the pieces that we have. And so what I'm going to do, just so that I can kind of keep it straight on my screen without having to scroll up and down, I'm going to redraw and rewrite what we found at the top. And you guys, since you have the sheet in front of you, you can just look up above. I just don't want to be scrolling because it's probably not fun for you guys. So we found that h equals c times the sine of a, and we found that h equals the a times the sine of c. Yes, it was a times the sine of c. So what I want to take a look at here is, since I have this h value and I have h in both of these equations, that means that I can set the other two parts equal to one another. So what I want to do is I want to say, okay, h equals h, so c times the sine of a equals a times the sine of c. Well, what I notice here is that I can make this a little bit nicer if I divide my right-hand side by a, so I divide both sides by a, and to get rid of the c on the left-hand side, I can divide both sides by c. And what that leaves me with, my c's cancel out, my a's cancel out, so I'm left with the sine of a over a equals the sine of c over c. So that leaves me with like this really nice ratio, so that the sine of my angle over its side length is equal to the side of another angle over its side length in the same triangle. So this is really nice in solving because now I can work with ratios instead of every single time, instead of having to kind of start from scratch. So now I want to see, how does angle B and side B fit into this same idea? So let's redraw our triangle ABC. But instead, oh no, A doesn't go there. But instead of having a height go from B down, I want to have a height that goes from C over. So now if I look at this same idea that I had done above, and I want to look at the sine of A, and I want to look at the sine of B to find that height. Well, the sine of A right here is opposite over hypotenuse. The sine of B is opposite over hypotenuse. And if I solve both of these for h, I get that h equals b times the sine of A, and I get that h equals A times the sine of B. Well, if you notice, this is very similar to what we had over here with A and C. So if I set these two h values equal to one another, I get that b times the sine of A equals A times the sine of B. If I divide both sides by AB, just like I did over here with A and C, I get that my B's cancel on the left, my A's cancel on the right. So the sine of A over A equals the sine of B over B. So this is really nice because now I have A in a ratio with C, and I have A in a ratio with B. So what that means for my law of sines, and you guys can think back to that transitive property that we hopefully remember from geometry. If A is equal to C and A is equal to B, then that means that C has to be equal to B as well. So what I can write here is that the sine of A over lowercase a, equals the sine of B over B, which is equal to the sine of C over C. So we have this ratio that we can look for in all of our side lengths and angles. So what does this mean when we're solving triangles? So let's take a look at number 3, and this is going to be a two-part question here. First, how many triangles can have the measures below, and solve the missing triangle measures? So for this first question, how many triangles could have the measurements below? We want to think back to our triangle congruence postulates that we learned in geometry. And I don't expect you guys to memorize them all, so what I want to do is I want to kind of write them off to the side here. So we can prove triangles are congruent using side, side, side congruence, side, side congruence, angle, angle, side congruence, what did I say? Angle, side, angle congruence. And if I have a right triangle, I can have hypotenuse leg congruence. So what this means is we're thinking about tracing the triangle. If I'm given side, angle, side, that means I have a side, the angle in between, and then another side going through. And that works for all of them. Angle, angle, side would mean I have an angle, then another angle, and then the side next to it. So in this triangle, what I have is I have an angle, and a side length. So right here, I do have one of these congruence postulates. I have angle, angle, side congruence. So what that means, how many triangles can have the measurements below? Since I have this congruence, I'm sorry, my computer's flipping out. I can only have one triangle. So solving for the missing measures. So what I'm missing is I am missing the measure of angle T. I am missing side length T, and I'm missing side length R. So what I want to do is I'm just going to write these off to the side just so everything is together. And I want to use this law of sines to solve. But I don't want to make this harder than it needs to be. So the first thing that I want to do is I want to notice I have two of my three angles. So I can easily solve the measure of angle T by doing 180 minus 49 minus 40 and find that the measure of angle T is 91. So I have 91 degrees for the measure of angle T. Now, solving for side length T and side length R, this is where we're going to want to start to use this law of sines. So, to solve for T, first I want to find one of these ratios that I already can fill out. So, where do I have an angle and its opposite side? Well, I have that with S and side length S. So what I can say is I have the ratio that the sine of 40 degrees over 20 equals, if I'm looking for T, I want angle T and side length T. So that equals the sine of 91 over side length T. And now I'm just solving my ratio, so I can use cross products right here. And I can say that T times the sine of 40 equals 20 times the sine of 91. And now I want to solve for T, so I'm going to divide both sides by the sine of 40. And when I type this right-hand side into my calculator, I'm going to get that T is approximately 31.11. And I don't have a label, so I can just leave it as 31.11. Okay, now to solve for R, I'm going to do the same thing. I'm going to keep using that sine of 40 over 20 that I know to be true from S, but now I'm going to set it up with a ratio of R and R. So angle R is 49, so I have the sine of 49 over R, which is what I'm solving for. Again, I'm going to do cross products, so R times the sine of 40 equals 20 times the sine of 49. Divide both sides by the sine of 40. And when I plug this right side into my calculator, I can find that R is approximately 23.48. And again, I don't have a measurement, so I can just leave it like that. So what I want you guys to do for part B is I want you guys to pause the video and try it. So see, do we have one of our congruencies? Is there only one triangle that we can create? And then solve for our missing sides and angles. And then I'm going to do it for you guys to check yourself. All right, in part B, we are looking for how many triangles. So I have an angle, a side, and an angle. So angle, side, angle. Congruence, is that a thing? Yes, it is right here. So I only have one triangle that can have these measurements. So that means now I want to solve for the measure of angle N. I want to solve for M, and I want to solve for P. So taking a look here, first thing, I have two angles, so I'm going to solve for the measure of angle N first, just because I think that is going to be the most straightforward. I'm going to do 180 minus 106 minus 56 to find that the measure of angle N is 18 degrees. And now I can go ahead and solve for M. So using my law of sines, I want to see, okay, what do I know both the angle and the side length of? Well, I know angle N and I know side length N. So I want to set up one of my ratios using my N values. So the sine of 18 over 1.5 equals, I'm looking at M, so 106. So the sine of 106 over M. I can do cross products. So M times the sine of 18 equals 1.5 times the sine of 106. Now I can divide both sides by the sine of 18. And when I substitute that right-hand side into my calculator, I get that M is approximately 4.67. So 4.67. Then when I want to solve for P, I'm going to keep using that same initial ratio. And I like to use that initial ratio just because I know that that's going to be the information that was the most given to me. And so it's going to be the most accurate. Like when we solved for M, 4.67 wasn't the exact answer. It was a rounded answer. So the more I use that rounded number, the more off that my answers are going to be. So I want to use the exact numbers whenever possible. So now if I'm solving for P, I want to do the sine of angle P, which is 56 degrees, over P. I'm going to do my cross products. So P times the sine of 18 equals 1.5 times the sine of 56. Divide both sides by the sine of 18. And when I solve, I'm going to get that P is approximately 4.02. So that is it for today. I'm going to let you guys do a little bit of practice, just getting more used to this law of sines. And tomorrow we're going to look at cases where we might not have one of these triangle congruence properties. So what happens when we do have something that could have more than one triangle? All right, guys, have a good day and let me know what questions you have.